Okay, so quick conversation on 162. I don't know that we'll go super detailed into this, but we'll give you a quick idea of what was supposed to happen. The 1 to 8 were easier than 9 to 20. Okay, so 1 to 8, what you were trying to do is, as always, in an ordered pair, put the first number in for X, put the second number in for Y. We can only say yes if the ordered pair numbers work in both of the equations. So you tended to say more no's than yeses. You can only say yes if it's like a double yes. If anything's a no, you have to say a no. Anybody have a thought? It's under half. Anybody have a thought on any yeses? Yeah, which ones do you think?
2, 5, and 6.
I agree. If you do that successfully, 2, 5, 6 should be a triple yes. The other ones, there's 5 of them that are no. Anybody a question about how you're trying to do 1 to 8? Or the details of that? Okay, so 9 to 20, what we had was called a system of equations. What makes something be a system of equations? What does that new word mean? There's 2 equations, and there's also 2 variables, and there may be more than that in future days. But on Friday, it was a 2 equation, 2 variable system. So what we did was solve these graphically. So if you take one equation, it's going to make a line. You take the other equation, it's going to make a line. Those 2 lines, if you do it right, on this homework, will always make an X. So on 9 to 20, each equation should make a line. Your 2 lines should make an X. Where is the answer? It's where they touch. Okay. Some other day, other than making an X, what could 2 lines do someday in our future? They could be parallel lines. Then what's the answer scheme?
Nothing.
There is not an answer. How else could the lines go?
Just the same line.
They could stack on top of each other. Then what's our answer scenario?
Everything.
An infinite amount of answers. But that did not happen in this homework. In this homework, the 2 lines should make an X. The X should touch probably on the corner of a square if you draw straight. But there were 2 of them I said that would have halves in them. Anybody spot one of the 2 that had the half square in it? Which team? 14 is. Yeah, 14 is going to involve a half square. So if you had trouble having 14 land on a corner, it's because that's one of the 2 that had a half square involved. And then there's one more that has a half square. 17. 17's our other half square. So 14, 17 are going to involve one whole number versus one half number. The rest of them should all land on corners. If they don't land on corners, you either need a ruler or you need to retry the lines and see where they go. Every number is also within 7 of the origin. So the farthest from the origin touch point is a 7. Anybody spot which answer has the 7 in it? 18. 18 has the 7 in it. I told you there was one that had a 5 in it. Which one has the 5 in it? 13 has a 5 in it. Every other answer is 4 to 0 in size. If that failed, I could do one of those quickly, but I want to make sure I leave enough budgeted time to make sure we cover the new lesson. But that's a scheme of 9 to 20 is each equation makes one line. The 2 lines should make an X. The X should touch somewhere at a corner of a square, except for 14 has a half involved in one number, and 17 had a half involved in one number. 18, the touch point involves a 7. 13, the touch point involved a 5. Every other touch point was 4 or less, and I'd say more 1s and 2s than anything. There's it's a quick skim. I feel like there's more 1s and 2s than there are 3s, although there are a handful of 3s. Anybody need me to do something on 162 that's like just going crazy on you? Yeah. 18. So yeah, that's a really 18 is the hardest one. So that's a good request. So So 18, I have I'm gonna say instead of 2b, I'm gonna go 2y plus x equals 11. And then the second one, I'm gonna say x minus y equals 5. So there's a lot of ways we can graph lines. And I'm gonna need to redo my scheme already because my chalk skipped, and if your chalk skips, that's not gonna be a good way to do a coordinate system for me. Let's graph this one first. Anybody a suggestion? How could we graph this? We could get the y by itself. Okay, so I'd have to leave negative y for a minute, leave the 5 for a minute, and get the x out of there. How can I get that positive x out of there? Subtract x. So then I need to go regular y. How am I going to get this switched up to a regular old y? Negative 5 plus x. Good on that? Anybody on that? Trouble? Okay, if we graph this, where are we going first? Down 5. So 1, 2, 3, 4, 5. And then the slope is an invisible 1, which is on top of a 1, which is telling us to move up 1 and over 1. I might do that a couple times. If you just do the 2 points, that's enough to do the line. But you might want to go up 1 over 1 again. Go up 1 over 1 a couple times. Sooner or later, we're going to land right there, and my graph paper here I created for myself is clearly crooked, because that's not really a straight line. But you could do as many of these up 1 over 1s as you want to help you get your ruler nice and straight. You don't have to limit yourself to 2. Here's another way we could have done this. Here's 2 special points. Those are called intercepts. If I go x of 0, y wouldn't be 5. It would be a negative 5. That would be the point here that I just found. If I go y of 0, x would be 5. That would be this point that I eventually bumped into. But we'd want to connect those with a straight line. Any of that's fine. You could have also made yourself a table if you really wanted to. Like, there would have been nothing wrong with that. You graph however you want to graph. Question about that one? This one, does this work well for intercepts, the way I did my zeros a second ago? Not so much. Why? 2 doesn't go into that. Getting this y equals is probably not the greatest idea either, because if you get the y equals, what are you going to have to do with the 2? Divide. And then these are both going to be fractions. So that's probably not your best idea. So you'll really only have one other thing, other than slope-intercept form, which failed us. The standard form, which leads to intercepts, which failed us. Point-slope form, you only use the right equations, so that fails us. What was the 4th choice that day that we used the least, but it's a tool in our pocket? Get it x equals. If we get this x equals, x would equal
11 minus 2y.
11 minus 2y. And what was that good for? Make a table and put the numbers in for y. If you put in 0, which we like to do, what's going to come out of that? 11. I don't know that we want to go 11. I mean, if you do, you do. That's up to you. If we put in 1, we'd get out 9. If you put in 2, you'd get out 7. But maybe you're better off putting in like 5, because you'd get out 1. Or maybe put in 6, and you'd get out negative 1. Well, 4 is not bad. You know, put in 4, you'd get out 3, something like that. But I know this isn't going to work out because I have not done accurate enough graph paper to go to 11. Okay, but if I did the points from those tables and I look for a touch point, it is going to be 7 something, which means it must be this. The 7, 2 is where we're going to hit. If we kept going up 1 over 1, up 1 over 1, that was gonna hit this 7-2 point on graph paper, and 7-2 is one of the points from our table that should be the touch point. Is that enough to make that possible for you? That was easily the hardest one, because that's the only one I believe you had to go x equals. I think everybody else you could do with intercepts, or you could do with the y equals style graphing. That was the only one you had to get x equals, and that was the only one that reached as high of a number of 7. So Emma just did everybody a favor on asking that question. Anybody have a general question about 162? Okay, well, I'll start the new notes. We're still in 4-1, phase 2. The homework tonight's going to go from 21 to 42 on that same page. If you're already there, you can see there's a new set of directions that say solve using a thing called the substitution method I'm about to teach you. And then they say solve using the addition method, which I'm going to rename and then teach you. But we're just trying to do this a different way. So I'll slide that way. In case you didn't figure it out, or notice when I told you this Friday, graphing is not the best way to solve these systems. Okay, there's just problems with graphing. What are some problems with using graphing as your tool to solve these all the time? What are some issues we're going to run into? Yeah, you might draw crooked and now it's just ruined, so that makes it hard. What's another downside of the graphing method? Yeah, and extra tools. You can only do it if you have graph paper and probably a ruler, and that's not necessarily handy. What trouble did we just run into a second ago? Yeah, it's crooked, now we're ruined. What's another problem we could run into with our types of numbers we could get? Yeah, we got 11 and we got a little grouchy. What if you got a number like 70, right? I mean, you could get an answer that's like 70, 903. Like, you're not going to want to count on graph paper, 903 squares. What other kind of answers can graph paper not really get you very well? Fractions or decimals. Like, on your graph paper, can you really tell the difference between 0.38 and 0.37? No. Okay, so that doesn't work for that. So while it's true and while it works and while it helps us understand the idea that this has a lot of answers and this has a lot of answers, but when they cross, it can only have one answer, that graphing can help us understand that. It's not really the best way to do these. Okay, so substitution is a better way. So this is what you want to do for substitution. Substitution, first move is get one of the variables alone. It doesn't matter which one, it doesn't matter which equation. You could either try to get the first x alone, get the first y alone, get the other x alone, get the other y alone, pick anybody that you want to bully into being alone, and go get that variable alone. Somebody make a choice here. Which one would you go after? The first y or the second y? I'd go after the first y. Or maybe I'd go after the first x. I'd go after one of these two. I wouldn't go after one of these two. Why wouldn't I go after these to begin with? I'd have to divide and I'd get a ton of fractions, and I don't want to do that. So I'd either get this x alone or this y alone. My advice from the front row was get the y alone, so I'll go that route. If I get this y alone, what is the y going to equal? 5 minus x. It would have been just as good to get the x alone. If we got the x alone, it would have equaled 5 minus y. It makes no difference which variable you get alone. Just pick one, get it alone. It's called the substitution method because then we're going to sub that into the other equation. So since y equals this, I'll circle that. That is going to go right here to replace the y. Y equals this xy stuff. So I'm going to go to this equation and replace this y with a bunch of xy stuff. 3x is still there, minus is still there, 4 is still there, 1 is still there, equals is still there. If I'm sticking a bunch of stuff here, what do I need to write here with the 5 minus x? Parentheses. It's a group of stuff coming, so I need parentheses to keep that as a group. So 3x minus 4, copy, 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 copy. Just replace the y with what we decided y could be replaced by as a fair trade. It's called substituting. Question about making that move? New life is over then. You've solved equations like this for years. We're down to just having x's because we substituted the one variables out and it's all xy stuff. If we had gone x equals, then it would have been all yzy stuff. No harder or easier, just look a little different. But how would we solve this from our Algebra 1 lifestyle? Distribute. So 3x minus 20 plus the 4x, be careful of our signs, equals 1. Then, combine like terms, x total, 7, minus 20, still 1. Get 20 out of there, 21. X must be 3. So the answer is going to be 3 something. X is 3, so I'm going to stick 3 into that first slot. So maybe that's like, I guess, step 3, solve for the one variable. Fourth step would be substitute into the circled zone. A minute ago I created a circled zone right here. Substitute into that circled zone to get the other one. So now that I know x is 3, 5 minus 3 makes 5 minus 3
2.
is 2. So the y would be a 2. Last thing, heavily suggested, even more heavily in this section than what you're used to, and even more heavily every year you go up the ladder in math, what all your math teachers always tell you to do that you just don't ever do. Check it. Plug it in to check it. You just did a lot of work. If you had made a mistake one time on one side, you're going to get all the wrong answers. Okay, so plug them in. To work, it has to work in both. 3 plus 2, did it work? Yep. 3 times 3 minus 4 times 2? Yeah, 9 minus 8, it works. In class, you get a false impression and think checking doesn't matter because nothing on the board ends up wrong because I'm holding the chalk. Okay, when you're holding the pencil and you're at home, more signs are going to go sideways. You also in the room have the collective wisdom of 16 people watching the problems happen. Like, we're just going to catch that stuff. Question about the scheme?
Where did you get the 2 from?
Once we got the one variable of 3, go back to where we started, and I'll usually circle the thing I started from. To get y's, just do 5 minus x's. So once we got the x to be 3, 5 minus 3 gets us to 1.
Okay.
I'll always circle that because I'm always going to have, where I start, I'm going to have to like finish back there too. And kind of around a big circle. Something about that first one? Good news is, they're all about the same kind of pattern. Once you kind of get a feel for this, they're all pretty comparable. The bad news is, it's kind of like a big amount of work. Okay, there's a lot of steps where you could miss a sign or make a mistake. You just have to stick with it. If it checks and fails, try it again. So here's our scheme again. We have to get any of the variables alone. It doesn't matter which one, but on this, there's definitely one that's easier to get alone than the others. Which the x off the second one. This x is easier to get alone because it doesn't involve dividing. If everybody involved dividing, then you just have to divide. Let's say this has a 2 in it, some other future question. Which number would you rather divide by out of 2, 5, 6, or 7? I'd say 2. I'd still be trying to get this x alone because like 0.5s are not bad. 7ths are terrible. The 7ths are like 12 miles long. So just if you had to divide, look to divide by like 2s or 4s or 5s. The decimals that don't repeat. But anyway, if we go get this x equals, x would equal 15 minus 7y. I'm going to circle that because where I started, I'm going to need to find that later. At the very end of this problem, that's what's going to give us the x. So that's step 1, get one of the variables alone. Now we're going to plug that into the other equation. We can't put it in where we were, you just be a dog chasing your tail in a circle, okay? If we use this one equation, now we need to put into the other one. So this needs to go replace the x. So 6 weights gets a new friend, still plus 5y, still equals 16. This top equation, just keep pretty much everything. But instead of the x, since x equals something new, put that new thing in. Question about how we jump that first hurdle. Now we're good. Now we're just going to have to distribute. So 90 minus 42y, still plus 5y, still equals 16. Then combine like terms, our y count. Close? Negative 37y. So there'd be an example of a thing, if we miss a sign, we'd have to chase that down later because things would go weird. Still 90 weighting, still equals 16. Get out of there the subtract the 90. That's going to be negative 74. Divide. It is 2. If you don't get a whole number, you're probably wrong. I'll look at the answers in a second. Common mistake would be to throw the 2 down. Why would it be a mistake to throw this 2 down right here? So it's the wrong spot. 2 is a y. Y's go second. So make sure you get y in the second spot. So where are we going to get x from? The circle thing. So circle thing will give us the x now that we know the y. We know y is 2, stick it in. Mathy math tells us 1. If it's an odd answer, check in the back of the book. That's the quickest way to check. If you're on a quiz, you'd have to plug it in. If you're a math teacher, you'll look at your notes, and on my paper of notes it says 1, 2. So yeah, we're good. That works. We're set. Question about substitution method. It's better than graphing. This will be better still, in my opinion. Question about substitution. When you go to work the 21 to 28 substitutions, there's one that will have fractions. So if you're doing the 21 to 28 and you get more than one with fractions, something bad happened. I'll tell you that the fractions will be fifths. So if you go to do one of these problems and you get stuck with some fifths, go decimal, leave it fractions, I don't care. But it's something in the family of the fifths. The other numbers are all whole numbers. There will be a 15. There will be a 7. Everybody else is between 1 and 4. So there shouldn't be any really like big numbers on this, other than the 15, I guess, is mid-sized. 7's not that big. But everybody else is 1, 2, 3, 4 family with probably more 2's than anything. Question about substitution before I cross the line? Can you wait like 10 minutes? Second thing, the book calls it the addition method, which is a fair name. I'm going to call it the multiplication addition method. I'll show you why in a minute. This one would live up to the name of the addition method, but the future ones are going to be multiplication addition methods. This is, I think, what we did on PSAT review. This came up briefly. So these two equations, since the y's are opposites, addition method, just add the equations together. What's going to happen if you add together these two equations? They'd eliminate the one variable. So I guess move 1 for this is create opposites if you don't have them. We didn't have to do that here. Mission was already accomplished. Step 2 is just add the equations together. And when you do that, the one variable is just disappearing. What would be your x count? 2x, once we add together, would equal 2 if we add together. So x must be 1. So what we have an answer so far, it's 1 something. For step 3, I'd say substitute that one variable anywhere you want. that has both variables anyway. If we know x is 1, you could put the 1 here and go get y, or you could put the 1 here and go get y. Do you like better the looks of equation A, or do you like better the looks of equation B? Probably A, because B has a bunch of negatives. Okay, if you want to go after B, you can, but I'd probably go to equation A. We know that x is 1, so if 1 plus 2y is 5, that means that 2y is 4, so y would be 2. And then I would always say check. Back of the book, plug it in. Teacher with notes says, yeah, 1, 2 is on my paper, so that's a win. That's a little easier than average. What made that one a little easier than average?
They were already on.
You already had opposites. Sometimes we'll have to work at that one. Okay. Question about that first one? This doesn't have any opposites. Okay, if you add this together, you just get something equally bad or worse. Okay, your 26 is going to happen. X's get bigger. The Y's just make new amounts of Y's. You can't right now add these together because you don't have the opposites to eliminate the way those did. So you have to create that. Are the X's closer to being opposites or the Y's closer to being opposites? Who's closer to being opposites? I'd say the Y's. Why the Y's?
One negative.
There's one negative, one positive at least. They're ready to go to battle with each other. So what we're going to do to create true opposites is multiply this by something. Multiply this by something else, and that's going to create opposites. And that's why I call this the multiplication addition method, because you usually have to multiply before you add. And I'm not claiming credit for that. The other people call it that too. I'm just saying I prefer that name because the addition method usually makes you multiply first. What could I multiply this one by one number and multiply this by a different number? What would those numbers be to like make the opposites happen? How can I do that?
4 and 3?
Yeah, multiply 3's problem by 4 and multiply 4's problem by 3. Just take the numbers that you're chasing and transpose them. If we switch. If we wanted to chase the x's, we could have also chased the x's. You'd have just had to multiply 2's thing by 3 and 3's thing by 2. But while you're doing that, you'd have to make somebody be negative. It wouldn't have mattered who, but we chased the y's, so we'll follow this through. So new top equation, 8x minus 12y is 28. New bottom equation, 9x plus 12y is 57. Good old Heinz 57. So we created our opposites. So now what? Time to add the equations. X total, 17. Y count is gone. Over here, 85. X would be 5. So the answer is 5 something or something 5? 5 something. Now we're to step 3. We could put that one variable anywhere. We have original equation A. We have original equation B. We have new creation C. We have new creation D. I would personally not plug into C or D, but I could. Nothing wrong with it. Why would I personally not really be as excited about C and D?
It's going to be a lot.
We made them numbers bigger. So why do the bigger numbers? I'd go after the smaller numbers. So A probably has the smallest numbers. There's a minus there, so if people are freaked out over that, then maybe avoid the negative. But I'd probably do A. I like the size of those numbers better. So if I put the 5 in, 2 times 5 is 10. Minus 3y is 7. So the negative 3y is negative 3. So the y is 1. And I've got a paper here that tells me 5, 1 is right, so I'm checked and I move on. One more and we'll call it a day. Question to that point? So we got to chase on this one. We don't have opposites, we're not even close. So we can either chase the x's or we can chase the y's. I'm going to chase the x's. Why am I chasing the x's? To make my life slightly easier. Smaller numbers. The numbers are a little smaller. So if I'm picking on 2 and 3, I multiply 3's problem by 2. I multiply 2's problem by 3. That's not perfect until I make somebody negative. Pick one. 2. So make one of them negative, didn't matter which one. So new top equation?
Negative 6x plus minus 3y minus 70.
Agreed. Bottom level?
6x plus 21y equals 135.
135 is true. So we created our opposites. Anybody question about how we created the opposites? Okay, then what? Add them together. That should always eliminate a letter that has the opposites. Why count? 13. Number count, taking it into mind that that was negative.
Negative 205.
No, this was negative, this
Oh
was
wait, no, I
positive.
was sorry.
Yep,
Negative 65.
regular old 65. So y, 5. And again, in the homework, I'll double check the whole number count, but I'd expect a lot of whole numbers. Common mistake is people will set up their answer area and throw 5.
5 gives it a second.
5's going in the second slot, y's go in the second slot. Then we can go literally anywhere that has the x that we're hunting to try to hunt x. So we could go to original level A or B. We could go to newly created levels, C or D. I would prefer to go to an original level, A or B.
A.
I like A a little bit better, but I don't think it makes a real big difference. If 5 goes here, we've got 3x plus 20 equals 35. So 3x, 15, x, 5. 5 just feels like one of those answers a teacher or a book would make. Like that's probably right. I'll check my paper. 5 is agreed. My paper agrees. So quick glance at the 29 to 40. From 29 to 34, they already made the opposites for you. So it's like that first one that I said was a little bit easier. The opposites were already there. 29 to 34, you've already got your opposites. Starting on 35, they're more like these last two where you have to create the opposites to add stuff together. From 29 to 40, there is one fraction, one time, for one of the numbers. And it's a half-based fraction. Everybody else is a whole number. So if you're not getting a lot of whole numbers, something is going wrong. And none of the numbers look very big again. In this section, there's one that has a 10. There's one that has a 6. And then there's a couple 5s, but it's 5s down to 0s for the vast majority of these answers. I would say the champion of this section is probably also 2s. I see 2s in like a lot of these answers, so if you're seeing a lot of 2s, you're probably on the right track. It's going to be harder at home than it was on the board, because on the board, again, we had the wisdom of 16 people to catch all our sign mistakes. So if you get to the end and you're dividing and it doesn't divide evenly, don't keep moving forward, because you made a mistake. Okay, it should, at every level of solving, divide evenly, except for, again, there's one question that's going to have a half. But it's pretty much going to make like 1, 2, 3, 4, 5s when you go to divide at the divide level. So don't try to work through a bunch of weirdness. If you're getting weirdness, fail. 21 to 40 is our new thing. Anybody question before we cut?